All right, friends and neighbors, welcome back. Now we are going to tackle troubleshooting for IPv4 routing. And so we're going to do a couple tools and we'll do a bunch of demos on how to help you figure out, what might be wrong with your topology. So here we go, troubleshooting IPv4 routing. So in this video, we have our key topics. Of course, I'll go over those really quickly. And then we have our exam section. This is all about network access. We're going to actually review some of our network management access. And then, of course, this is really about troubleshooting. And so IPv4 connectivity, we're going to take a look at the static routing. I have a topology configured for you. And of course, remember from the previous videos, the different kinds of routes we have. So we'll take a quick look at some of those. And this chapter has no do I know this already question. So here's our key topics, right? We've got tables. Our forwarding rules are all about the tables that we have. So we have the host routing, host ARP, we have a switch SAT, we have a router ARP, we have a router routing table. So lots and lots of tables. Get to know those tables, get to know the operation, and you've got it down. We're going to do some pings. We'll do that from the routers and we'll do it from the host. We'll do a comparison and then see some advanced pings. And then we'll talk about some of the reasons why they fail and what might be the symptoms that you get as a result of some of those failures. And then I've got a host configured that has a default gateway and one that doesn't. And so we'll see what happens there. And we'll do some really basic DNS configuration or IP host configuration stuff on the router. We'll talk a little bit about that. And then, of course, we're going to do traceroute, problem isolation using ping. Ping has got to be one of the most popular troubleshooting tools that we have out there. We call it proof of life. But it is really a program that generates ICMP echo requests in the hopes of getting an ICMP echo reply. So it's also sometimes called the responder function. There is no TCP or UDP involved here. It's just an ICMP message encapsulated in IPv4 or v6 and then in Ethernet or 802.11. Different OSs have different behaviors, and we'll take just a real quick look at that. But we just have to realize that when you're on Linux, that behaves different than on Windows, which behaves different than on a Cisco device. Now, there is a difference between pinging from the host and pinging from the router, because the router, a lot of times, in addition to its different perspective on the network, it might know some things that the host doesn't. Now, when we get a ping back, sometimes we just want an answer, right? I pinged you and I got a reply, so that's good. But ping can also be used for a little bit of timing. And so this bottom here is an example of some of the additional information. We have packet loss here. How many did I send? How many did I receive? And therefore the loss. But also we get a feel for the round trip times. And so we get a max, a min, and an average. And these can sometimes help us when we're trying to troubleshoot some delay issues. Now, like all troubleshooting or problem solving, we have a strategy or a methodology that we can employ when we are doing our pings. So one of the things that we do is we say, oh, a trouble call comes in, I can't get to the internet. And so a simple question is sometimes, well, what can you get to? And this leads us down the pathway of saying, well, okay, what is available to me and what isn't available? And that helps us diagnose the problem. So for example, well, I can't get to the internet, but can I get to my default gateway? And that really isolates or helps isolate the problem. If you can get to the gateway, well, it might not be a host problem. If you can get to the gateway, but you can't do anything with names, then it might be a DNS problem. So there's lots of ways to help isolate. The other thing you can do is say, well, can you ping your neighbor? Can I ping anything else that I might get to or might need to get to? And so these are ways to help narrow down where the source of the problem might be. So we're going to try to go over a couple of scenarios here in the demo, right? What happens when a host is missing a gateway? What happens if links are down? What happens if your router doesn't know the answer to the destination? So we'll break a couple of configurations and see what we get as a result of that. And then what happens if the router along the way doesn't know the answer? But those sort of point in the outward bound direction. What happens if you try to ping something And the problem is not in the outbound path, but rather in the return. In other words, the routers don't know how to get back to you. These are different problems. Now, the book talks about several root causes for failure: an IP addressing problem, an IP mask problem. Now, I've got a note on here. Look at our topology. In this chapter, all of the examples are 172.16 networks, and that would indicate that you're going to do /16 somewhere, right? But because the important part of the addressing is in the third octet, these are all /24s, and that's important to realize. It's really easy to screw up the masks and therefore change what a node is going to do or is willing to try to do. If we have a DHCP problem, right, if a node tries to get somewhere, now users don't know about DHCP or DNS, but if they can't get an IP address and try to go somewhere, well, that's obviously not going to work. And so DHCP problems, VLANs or trunking problems, right? Did you prune something? Are you in the wrong VLAN? These all cause problems. And don't forget your layer ones. Users also don't realize that they need link lights, cables go bad, ports go bad, all of these things. So we can have layer one problems in addition to all the other things that might go wrong. So we just don't want to forget all the places where we might need to look. Now, the book also talks about extended or advanced ping, additional commands and abilities like specifying the source IP address for the ICMP echo. Now, we'll do a demo of this and we'll see the impact of it. But basically, it comes down to this. If a router is trying to respond, or if you ping from a router, it's going to pick the interface that's on that direction. But that leaves out some troubleshooting steps that you might take. So the extended ping gives us the ability to specify connectivity to any one of the router's addresses. So you can substitute a different source IP for the ping. And I'll show you what that means here in a minute. I added here that there are additional features that are not just for Cisco, and the screenshot on the side of me here shows all of the possible options that you have from a Windows host or from a Linux host or a Mac host. There are piles and piles of options, but people don't use them. So for example, you can specify that you want to record the route. You can specify the hosts over which you want this traffic to travel. And so the IP header can actually expand to include a whole bunch of IP addresses that you want to use on the way out. And so it's sometimes fun just to experiment with the tools that you have. Let me show you a quick example. So here is the output of ping, right? If I do ping without any arguments, and I see all of these things that are available to me. So I might do, let's just take an easy one. If I do ping-n2, and then I go out, right? So this just says, well, I'm going to do 2. But I can also do a ping-L, for example, and I might change the size of the ICMP packet that I send. And what this does is it sends a much larger packet and allows me to experiment with things like fragmentation, which may or may not be allowed. And so these are important tools that you can use. If I change the IP address here, now I get a response. And we can see that I'm actually sending a much larger packet. And those are just 2 examples, but I can also see that I can use ping with IPv6 just to get you started. Okay, now the minute we start saying things like names, we're probably talking about DNS, but we might be talking about some other mapping, a local mapping of IP host name and IP address. And then we can ping based on names as well. So there's nothing at all that says that you can't ping to a namespace. Now, the nice thing is that this tests a couple of things. This tests not only connectivity, but also tests DNS lookups. Remember that DNS is actually kind of like the phone book for the internet. So when we talk about IPv4 addresses or IPv6 addresses, we're talking about the address space. But of course, people don't use addresses like IPv4 addresses. They use names. www.cisco.com. These are all part of what we call the namespace, and DNS, or the domain name system, is the thing that maps names to IP addresses. And so there are a couple of commands that you can use on a router to specify that you want to go to a DNS and use those lookups. I don't have a DNS configured in Packet Tracer, but I'm going to use another command to show you sort of what it looks like. And then we did the IP domain name because we're going to do SSH. All right, let's do a couple of quick demos. First up, I just wanted to show you that you can ping an address. So if I wanted to ping YouTube, for example, I can ping a name. Now, what actually happens? Well, the first thing that happened in order for this to work is that I had to do a DNS query, get the IP address of YouTube, and then I actually pinged the IP address. So that's what we mean when we say we can ping a name. All right, here is our packet tracer topology, and we're going to do a couple things here. The first up is we're going to ping around when we don't have a default gateway. So here is 172.16.1.2. It has no default gateway. So when I ping around, there are things that will work and things that won't. So if I try to ping somebody on my network, 1.1 for example, that works. That's this host right over here. If I want to ping my default gateway, well, that works too because my default gateway is on my network. But what happens when I ping somebody that's off of my network? Well, the host says, I'll try, but I don't have a default gateway, and that host is not on my network, so what do I do? Now, this is related to another problem. So I don't have a default gateway. That's why this fails, right? I never attempt to go to my default gateway. Now, we can verify that. If we take a look at the simulation, right? And I do the exact same ping. Let's see what happens. We'll put this down a little bit. Notice that the packet never actually goes anywhere. And this is because the host says, well, I processed my host routing table and I have no idea how to get there. Let's try something different. Let's try a mask problem. So now I'm going to go to my fast Ethernet interface and I'm going to change the mask from /24 to /16. Now this host believes that instead of being on the 172.16.1 network, it now believes that it is on the 172.16 network. And we're going to do the exact same thing. We're going to try to ping, and we'll see what happens. So we're going to run our simulation again. Now what happens? Now this message actually goes out. Why is it going out? Well, the host believes that it's on a much larger network, that the destination, 172.16.4.1, is not on a different network, that it is in fact on the same network. And so it goes out, but of course, that host is not out there. So 172.16.1.2 believes that it can get to the destination. Well, let's take a look at a different host. Now this host does have a default gateway, and it has the correct mask. We'll do a couple of examples here. All right, so I have passwords set up, so we're gonna go over those later on. If I take a look at my routing table, I can see that right now I know how to get to the 2net. I'm going to take away this network. IP route 172.16.2.0. And the reason that I'm going to take this away is because I do not want this router to know where it is, because I want to see what result we get when we ping. So now if we do a show IP route, we only know about the directly connected networks. Okay, so now I'm going to ping 172.16.2.0 2.1. Now that is this node on the other side of the topology. Now this is really important. This comes back from 172.16.1.254. And what that address is telling us is that I don't know how to get to the 2 network. Well, what does that look like in traffic? So it goes out from the host to my default gateway. Please help me with this. And we see that the router sends back an ICMP destination unreachable. So what we've got here is that you tried to go to this destination and I did not know how to get there. So this is an ICMP destination unreachable, type 3 destination unreachable. So that is the result of a router not knowing how to get there. So my default gateway doesn't know how to get to the destination. Well, let's fix that. And let's create a different problem. I'm going to go over here on this router. And if we take a look at this routing table, now there are only 3 networks here. Now this router knows how to get to all of the networks here, but I'm going to take away the 1 network. And so the difference here is that my traffic will know how to get out, but it will not know how to get back. Okay, that's an important distinction because our results differ. Here it's clear that a router, if it doesn't know the answer, is going to tell me that it doesn't know the answer. But now if I ping, what happens? Well, now this is real time, so the traffic is attempting to get out there. And it times out. So let's take a look in the simulation and see what happens. So the traffic goes out now, but we've told R1 how to get there. So R1 forwards it, and it gets all the way to the destination, right? Gets all the way there. And 2.1 has a default gateway, so it sends it back to its default gateway, but the default gateway does not know how to get back to the 1net. And so it's the same thing, but the problem is if we are troubleshooting from this host, we cannot see the answer. We cannot see what happened. We just get no answer. So it's a little bit like a black hole. We just send it out there and we have no idea where this actually broke. And so these are 2 important differences that we get when we're taking a look at the output from ping. Okay. Well, we saw that Windows uses a default of 4 pings. Linux is continuous ping. Let's fix what we just broke first. So now we're back to a fully functional topology again. And let's try pinging from a router because this is something that we can do. And we can say ping 172.16.1.1, right? Now we see, first of all, that Cisco uses 5 pings. And if we were to open those up and look at the content of the message, it would be a little bit different. But that's not actually what we want to see from ping at this point. We want to talk about that extended ping. So if I ping 172.16.1.2, so I'm going to ping this node down here. And I want to use the simulation here because we want to see the address that it actually uses. So I'm going to do this. So the ICMP goes out. Now one question then is, what is the source IP address used by the router? Well, the router uses 1.254 as its source. It uses the interface that's closest or in the right direction to the destination. But this really doesn't test very much, right? So what we're going to do is we're going to use extended ping now. And we are going to specify a different IP address. Now, what this allows us to do is understand a little bit more about what the topology knows or understands. If we were trying to diagnose something, we might want to use a different IP address to determine how the routing is set up or if the routing works. So if I just use ping without any arguments, it starts asking me questions about what I want to do. So I'm going to say we're going to do IPv4. The target IP address is still 172.16.1.2. The repeat count is 5. Okay, now I could change that. Datagram size 100. Okay. Timeout. Okay. Extended commands. Yes. Now this is where I get to specify the different address. Now I can do this from whatever interface the router has. So I'm going to use 172.16.4.1 as my source IP address. Type of service, DF bit, no. There we go. Okay, so if this goes out now, we can see that my source IP address is now 4.1. And what this does is allows us, if we were testing the connectivity between routers or testing interfaces or networks, right, this will enable us to test whether or not my routes are all set up. That is what we mean by advanced or extended ping. Okay, problem isolation with TRACEROUTE or TRACERT in Windows. Another extraordinarily common troubleshooting tool, very widely supported and used. Like ping, it depends on other hosts to send you messages back. So you send out messages and you're hoping that devices along the way are willing to respond to you. Its use is a little bit different than ping in that you're trying to test router interfaces along the path to the destination. That also means that you can test multiple devices along the way with one command. The path that we're testing is also called the forward route from source to destination as opposed to the reverse route. This is also a collection of the next hops along the way. Now, I suppose it's important to understand how TRACEROUTE works. The key is in the time to live field in the IP header. Every IP packet has a time to live associated with it. And if that time to live is decremented down to 0, the router that does that says, I can't forward this anymore. And it sends back to the host an ICMP time exceeded message. That's how we remove continuously circulating packets or packets that are caught in a loop. Now, TRACEROUTE leverages this by sending messages out first with a time to live of 1, and then with a time to live of 2, and then a time to live of 3, and so on. So the first router gets it, the time to live is 1, it decrements it to 0 and sends a message back. And you go, aha, I know the first hop out. And then you send another TRACEROUTE message, actually an ICMP message, out with a TTL set to 2. So it gets by the first router, gets to the second router, and then the TTL is back down to 0, and that router responds, and so on and so on and so on. And of course, we have extended TRACEROUTE as well. So here is a host that has the TRACERT command, and what I'm going to do is we're going to trace to the other side. Now, this is not from the router, right? But this shows you the hops along the way. So this is my default gateway. There's the next router in the line. That's this one here, and then finally the destination. But of course, what this is telling us is that you can also use TRACEROUTE, or the fully spelled out TRACEROUTE 172.16.2.1 to the same destination, right? So Cisco devices and hosts both have TRACEROUTE, and it's really important to understand how that works. So let me do the, we'll do it from here. Do the same command again, and we'll do the simulation to show us how it actually works. All right, here we go. Trace route. All right, now when this, we'll let it go out to the multi-layer switch. There it goes. And if we take a look here, again, what we're looking at in the IP header is for that time to live right there. So the time to live is set to 1. And so each router that touches it decrements that field. And here we see that the R1 has decremented the field to 0. And so now sends back a different type of ICMP message. Okay, so there's our type. This happens to be a time exceeded message. And this goes back. Now traceroute actually repeats this action a couple of times. Oh, now what just happened there? Let's grab the one from the host. There we go. We can see here that the time to live is 2. So R1 decrements this by 1. And so the message that goes from R1 to R2 has a time to live of 1. Okay? And then R2 decrements this to 0 and sends the ICMP time exceeded message back. And we can see this comes from 4.2, and it is another time exceeded message. So we'll bat this back and forth a couple of times, and at some point we will increment the time to live to 3. And I think this time will be the one. Okay, so let's see what this one has. Time to live of 3. So that means R1 will decrement it to 2, R2 will decrement it to 1, which means it'll get all the way to the destination at this point. And there we have it. So that is how traceroute works. Now, like the extended ping, we also have extended traceroute. And it's the same thing where you can specify the target address, but the important part is being able to specify the source address. And that would give you an opportunity to test different pathways, or at least test the response to different source IP addresses. Now, ping and traceroute are both terrific tools. I would absolutely encourage you to come to know and love them as I do, but they have limited visibility and they can't show you how something is configured. They can show you where problems are, and then you can sort of make some suppositions about what you think is wrong, but what we really need sometimes is access to the device. So Telnet and SSH. And so today we're going to remind ourselves how to SSH to a device. Now the really cool thing is that routers and switches also have SSH clients. So that becomes really, really helpful if we can't get to a device from another device, but we can SSH to a device that's closer. And I'll show you exactly what I mean here. It also allows us to hop around a little bit between devices if we believe that something like a routing protocol is misconfigured or we have some other connectivity problem. Now I'm going to do some review with you. So I'm going to recall you to chapters 4 and 6 for some of the configuration that we're going to do. Now, just as a reminder, we can have passwords of all kinds. So we can have login passwords, we can have enable passwords. You can have different passwords for different lines. You can have local names and passwords. You can specify the transport type on a line. And then, of course, when you decide to do SSH, it has its own configuration, right? The host name, the domain name. You got to generate the keys and have a user account to do that. Well, let's take a look at what I did for that. Now, first up, I'm going to point out that I've got this node here. This is a console connection. And so we'll start there. So I'm going to use the terminal. And we're going to configure. Now I'm going to go all the way out, right? And I just want to connect via the terminal. This is not an enable password. This is as soon as I go to connect. And so I've got a login right here. That gets me to the user prompt. Now I have an enable password. So that was a different level entirely. So let's take a look at the running config and see what I did. So I have this first enable password. Remember our host name command that helps me keep things straight, mostly because the prompt is there. I've got this username that I created for myself. We'll use that here in a second. Oh, I just realized SSH version 1. Very, very bad. Now this is, oh, I forgot to do this. We'll do this right now too. So this is the IP host command that allows me to ping by name on a router when I don't have DNS active. Let's see what else we did. Let's go down to my line commands. Now this is the login requirement for my console. And here is the login requirements for my VTYs. So what I'm specifying here is that we're going to require logins on all of these things, and that in this particular case we're going to do some SSH, but we can also specify that I'm going to be using some local accounts to do this. So these are why we have all of these different layers of passwords and logins and everything else. Now before I leave here, I said that we could do a ping. Now if I just ping R2, okay, we get the success rate, and what it's actually doing is pinging r2.example.com, which is this definition that I made up here. Okay? All right. Well, that is our sort of reminder about all of the logins. So now let's go ahead and remind ourselves about the SSH connectivity. So here is, we're going to do, let's do this one first. Well, first we'll try to ping 172.16.4.2. That's this side. Why is that working? All right, so I just realized that some of my wonky behavior here has been because I forgot to change the mask back, but here we go. Let me, let's take an example here. If I try to ping 172.16.4.2, right, it doesn't work. I can't get out here, which also means that I couldn't SSH to that particular device. But if we remember that I created a username and that my router has an SSH client, then here's a way that I might get away with this. Okay, so what I'm going to do is we're going to close this, and I'm going to use the SSH client. So I'm going to SSH to 172.16.1.254, and I'm going to use the username Bruce, which is the one you saw that I had set up. And this will be the password that I have for that account. Okay, now I have the enable password, which was hi there, I think. Okay, so now I'm SSH'd over to R1, but we know that 172.16 can't SSH to 172.16.4.2 because I forgot to do the default gateway. I can use the SSH client on my router. Let's do this right. SSH. So I can use the SSH client to log into a neighbor from the router that I just SSH'd into. So I'm going to use the same account. Oops. And now I'm going to go, all right, what IP address am I going to? Well, now let's see if I can get to 4.2. And the answer is I can, because router number 1 has the ability to get to router number 2. So take a look at how the prompt changed. So now I'll do enable here. And now I have the configuration of router number 2. If I exit out of this, notice that the prompt now is back on R1. So there we see that I can not only SSH from a host to a router after configuring the host for SSH, right? We got to do the username, the domain name, the host name, the crypto key generate, and then set up our transport in with SSH if we want to specify SSH only. But then, of course, we're going to do not only this connection, but we saw that the router itself can be used as an SSH client. Now, the really nice thing is that from here, I can hop all over the network. In fact, I could SSH to a router 2, and then from there, SSH to someplace else. But there we go, SSH and the SSH client on the router. Well, the reason we wanted to make sure we had a handle on this chapter, and we wanted some troubleshooting tools, that we really wanted to understand our static routing and really be able to troubleshoot it. Why? Because we're about to do OSPF. So the Chapter 21 look ahead is routing measures. We're going to talk about metric and admin distance and even prefix length. Understanding OSPF concepts, we're going to do a single area OSPF build. We're going to talk about adjacency, point-to-point areas, broadcast areas, and the router ID. Going to be very exciting, our first routing protocol. All right, this has been Chapter 20, IPv4 route troubleshooting, or static route troubleshooting especially. We went over PING and TRACEROUTE. We saw that there are both standard and advanced or extended versions of that. We reviewed logins, right? We can log into, we can have a password on the device, an enable password. We can do SSH passwords with user accounts. And hey, we figured out that routers and switches have built-in SSH clients themselves, so we can hop all over the place. Whew, good stuff, good stuff. Hey, like and subscribe if you are ready to troubleshoot, and may those packets always reach their destinations, no matter what kind of transport you're using. Remember, this is CCNA. We're heading for OSPF. You can do this.